Today I'll give you a talk that was actually originally and it still is, a conference presentation. But what I've tried to do is add a few kind of introductory slides to really kind of bring everyone to the same level in terms of appreciating the problem. Because I know it's quite easy for researchers to just launch in as if we all have the same common assumptions. So to do that, I thought it would be useful to kind of compare what I'm talking about in this talk, privacy preference signals, to maybe the non-digital equivalent. And to me, the clearest example of that is affirmative consent, which maybe if someone could put the German translation of consent in, just in case it's not clear. This is used in various settings. So if you go to the doctor, say, there's normally a conversation between the doctor and the patient to establish that, you want the treatment, that it matches with your maybe religious preferences, whatever, because, also with research, when we can conduct research with human subjects, we kind of try to collect the consent, explain the purpose of the study, and ensure that the participants agree. Also, and this is where this image comes from, particularly in US and UK campuses, there's been a big kind of movement to raise awareness about consent in sexual relationships. So the idea is before, there's kind of sexual acts, there's at least some form of affirmative consent. And then now that will lead us on to kind of, the purpose of this talk, which is digital consent for data protection purposes. And what we're talking about, privacy preference signals, is maybe slightly broader than affirmative consent, but keeping this in mind should give you a rough idea. So to make this a little bit participative, I wondered if anyone can kind of talk about, or at least see the common thread through these four contexts in which affirmative consent is looked for. And there's no right answer here. That's kind of why I'm interested in what you think. Maybe these seminars don't work like this. I mean, I can give my answer, which is, by no means completely correct. But it's kind of serves two purposes. One is to raise awareness about what is happening. And the second is to kind of negotiate personal preferences. So if you think about, say, medical research, at least a lot of the movement towards collecting consent in a medical setting originated in some of the experiments during the Third Reich, where essentially humans were experimented upon without any form of consent. And so the medical community tried to establish this. And I guess the important thing here is there's always a power imbalance. So the doctor, as someone who administers medicine, has power over the patient. The researcher who knows what's happening in the study has power over the subject. In a sexual relationship, maybe one party has more power because they're, physically stronger, or they, let's say, are less, intoxicated, for instance. And then in data protection, we can also see this power imbalance. Often we as individuals are kind of getting a service from these huge American corporations, Google, Facebook, Amazon, where maybe you could argue there's the same level of power asymmetry. And I think what's also important is to see the difference between these contexts. For medical consent, if you are a reasonably healthy person, you're maybe having a few procedures every year, most likely less. So you can afford to have this conversational form of consent where there's a kind of real-time interaction. Similar for research, most participants are just kind of in a research experiment a few times a year. It depends how, I'll leave the third one to your imagination. But the difference here, I'd say, for data protection is we as web browsers, for instance, people who browse the web, are often interacting with many different companies. And that's both when we visit many different websites. Each of those websites might collect data about us. And also within the same web page, there's often multiple parties in that. There's an advertiser, maybe multiple advertisers, also data, people collecting data. So yeah, this is the big difference with privacy preferences on the web. We can't have this form of dialogue, and we maybe need an automated way of expressing our privacy preferences. Or not necessarily automated. And that's where privacy preference signals come in. The idea is that rather than have this kind of human dialogue, we can just send a signal that in a very concise digital representation summarizes what that user's privacy preferences are. Now, I think naturally some of you will say, well, sure, users can say what they want. They can say, I don't want to be tracked, but the big technology firms will do it anyway because they have that power imbalance. And yeah, I think that's a fair perspective. There's a lot to say to that, but also what I'd encourage you to consider is there are some reputational considerations in there. Some of these companies don't want to kind of abuse the user's privacy preferences. And the second thing is there's also a kind of legal regime surrounding these things. So I'm sure we're all aware of the General Data Protection Regulation, which came into force in 2018. But within that law, there's kind of, some, for instance, Article 6 that pushes companies towards collecting consent, which would potentially respect these privacy preference signals. So the kind of final thing I want to express is there is this question of why does there need to be a conversation? Why can't every user have maximum privacy? Why does there even need to be tracking on the web? And I think, again, there's something to be said for that. But what becomes difficult is often we need these companies to track us in order to have the service we expect. So if you go to Amazon and you're maybe shopping for Christmas presents, you want to keep that basket full with the things you've already selected. So this is an instance where Amazon needs some way of identifying the user so that you can kind of track what's in your Amazon basket. Similarly, if we think of some of the social media companies like, let's say, Facebook, we want some way to track the user so we can show that user the friends that they've kind of, through the process of using the app, identified, or maybe the messages. So kind of what I would say the fundamental privacy trade-off is that we need some level of tracking for these services, online services that we all enjoy, but also what we don't want is the kind of invasion of privacy. So there's this very complex balancing act. And again, many people would disagree with this, but within the kind of paradigm around the General Data Protection Regulation, the notice and consent paradigm, the argument is that these decisions are made on an individual basis. Maybe you have some users who, for whatever reason, have a greater demand for privacy, and they want to negotiate that. They want to say, yeah, you should track me less. And kind of the only way to have that very tailored approach is if the user can negotiate their privacy preferences. So that was a somewhat long introduction, but I just wanted to get everyone onto the same page. There is the potential for users to express privacy preference signals, and there's also a reason to do it. This could potentially ensure that we have the privacy that we demand. And what you will see throughout this talk is basically that privacy preference signals don't deliver the privacy that we kind of hope they did. But maybe it's useful to go to a concrete version of this so you can start to understand. So this was launched in the early 2000s. It's called the Platform for Privacy Preferences. And the idea here was that users would be able to say, these are my privacy preferences. This is how I want websites to use my personal data. So that's one side of it. The second side is what the websites and advertisers would do. And they would say, this is how we use your personal data. And the idea was that the browser, who sits in between those two parties, would be able to say, okay, so this user doesn't want to be tracked for these purposes, so therefore we will block this advertiser. This is kind of the rough idea behind it. So you can see here, I hope you can see this is in the Internet Explorer browser. We have this scale that we can tweak. So if we push it up to maximum, maybe it provides maximum privacy. It blocks more websites. If we pull it down to be relaxed, then it lets those websites track us. So this is actually interesting because not only is there a privacy preference signal, and I would say the privacy preference signal is on the user side when the user tweaks that slider, so it sets its privacy setting at medium. That is the user expressing their privacy preferences. But we also have that the websites have to express their kind of data practices in a way that you can directly match and compare. So this seems like a great solution. Some of you may remember it if you were browsing the web back then. And it was adopted by a reasonable number of websites. So depending on the study, it's between 2 and 10% of websites. Another study actually found that 15% of the AdTech vendors in their sample adopted platform for privacy preferences. So this seems really encouraging, right? This seems like a way that users can demand a certain level of privacy that matches their individual preferences. Now, as we all know, this was never realized. And one of the reasons behind that is the only browser that implemented this was Microsoft Internet Explorer, and they kind of fudged it. And by fudge it, I mean, essentially they allowed, if a website misconfigured their data practices, so rather than saying, we do this, we do this, we do this with your data, instead it would somehow get that wrong in a way that just didn't make sense. Microsoft chose, and this was just a design decision that they made, to just let that website do whatever they wanted with the data. So rather than having the browser enforce privacy practices, what essentially happened is Microsoft gave a free pass to these websites. And what we found, well, not we found, a different study found, is that 3,000 websites essentially copied the code from the Microsoft support page that described how this kind of could happen. And they copied a deliberate error down. They just copy and pasted the deliberate error in. That meant they got a free pass. So, this was the first privacy preference signal adopted in over 20,000 websites, but only Internet Explorer. But kind of as we know now, it never became widespread on the web. And actually, you'll see here, it was deprecated in 2007. So now this brings us on to the kind of second one, DNT. This is a completely different privacy preference signal. And it started development around about when P3P was failing. So DNT is perhaps the simplest privacy preference signal. It just sends, regardless of who you're communicating with, it just sends the simple signal, do not track me. So this is kind of asking for maximal privacy. A lot of privacy advocates really liked this solution because it makes sense. It's simple, it's hard to misinterpret. It just sends the simple message, I do not want to be tracked. Now, the kind of cynics among you might ask, why wasn't this adopted? And actually, a lot of the browsers did adopt this. So whereas P3P was only adopted by one, Microsoft Internet Explorer, Do Not Track was also adopted by Mozilla, Safari, the Apple browser, and also Google Chrome eventually adopted it. But the problem here is that none of the AdTech vendors accepted it. And they had some quibbles. They didn't like that, for instance, Microsoft Internet Explorer turned this on by default. So if the user didn't toggle the settings, by default, Internet Explorer would send Do Not Track. And what the AdTech vendors said was, look, if it's turned on by default, then it's a meaningless signal. So we don't need to respect it. We don't need to see which users are sending it. We're just going to ignore it. So arguably, do not track was killed by the AdTech vendors. Because if you're sending a do not track signal, but the people who are actually tracking you don't even respect it, then there's almost no point sending that signal. So what you'll notice in this kind of diagram is there's a big delay. So it's not until 2018 before the next sets of privacy preference signals were introduced. And what you will also notice is this is kind of coming into the contemporary time when we as researchers can measure it and our measurements will be meaningful. So that's the next thing we look at. Okay, so no doubt everybody recognizes this dialogue. It's all over the web. And yeah, it's kind of interferes with our browsing. But what you will notice is, well, you won't notice this, but I'm telling you it, is underlying this dialogue, which is offered by Quantcast, there is a signal that is defined in the transparency and consent framework. This is TCF. There are other dialogues and they all use the same signal, but it all follows this TCF format. So you might ask the question, who designed the TCF format? And it was actually designed by the AdTech industry. So companies like Facebook contributed to it. Quantcast, the company here, who are one of the biggest kind of AdTech solutions providers, also contributed. And what our study, the kind of main part of this presentation looked at, was how widely was this TCF privacy preference signal adopted. So just to be clear, TCF equals AdTech signal. And what we found was that over 8,000 websites, this was 8% of the top 100,000 websites in the world had adopted it, and probably most significantly, over 600 AdTech vendors had adopted it. So I'll just introduce now a few more detailed graphs to explain kind of how that changed over time, and also to ask the question of what caused the websites to adopt this signal. Because what you will probably all recognize is that these dialogues are really annoying. So why does the website even adopt it? Because the dialogue annoys us, the users. So why has the website adopted it? Okay, so this was basically the methods we used. This was Max Hills, who's a PhD student here at the University of Innsbruck. It was his master's thesis. So basically he collected a lot of websites, 7.2 million. In this sample, a slightly different sampling method of 100,000. We can speak more about that in the comments if people are interested. And what you can see here, using the methods in the previous slide, you can see how adoption of this privacy preference signal, TCF, the AdTech signal, changed over time. So if you look down here, you'll recall that the GDPR came into effect in May 2018. So that's here. And within a few months, there was already 400 vendors who'd adopted the TCF signal. You might ask, why did they do that? And then you could reason about things like the AdTech industry designed it. It only defines opt-in consent. So if a vendor receives an opt-in signal, then arguably it's a free pass to track that user. And basically what we saw was that the AdTech vendors, unsurprisingly, rushed to adopt this signal. Yeah, maybe that's a detail we don't need to visualize. So then we could ask the question, we've seen how AdTech vendors adopted it. They all adopted it very quickly. But how about websites? And here we see it's much slower. So here you'll see the GDPR comes into effect again in May 2018. And slowly but surely, you see this line rise. And it rises up to about 8,000 here. So this means that 8,000 websites now use that Quantcast dialog that you saw before to collect TCF signals. A few things changed over time. At first, Quantcast were charging for websites to use that signal. But then in 2020, they decided, you know what, we'll make it free. Websites can use our dialogues for free. You might ask yourself, why is an AdTech body providing a free solution? And the answer that I would suggest is that it's free because websites collect consent for companies like AdTech, and the consent enables their business model, which is based on personal data, to continue. Okay, so here we're kind of, you can see from, or you can hear from my implications why I think websites adopted it, but we can try and drill into that with some specific tests. So this is a graph that shows for each web page, essentially, when you look at a web page, it's pulling content from many different domains. So the first domain, if you go to, I don't know, Der Spiegel.de, I don't know why I used a German website. Maybe some of that content is the news article that's provided by Der Spiegel, but maybe other parts of the web page are advertisers or trackers. And what this graph, the x-axis tracks, is the number of other domains that provide content for a web page. And as we see, the more domains who are kind of providing content to a web page, the more likely it is that that website adopts the TCF standard. This is the pro AdTech signal. So this is kind of building up a picture that actually it's the website's business partners, the advertisers and the trackers who are pushing websites to adopt TCF. I would caution you, in the paper, we are much more kind of considered about this because the evidence isn't quite there. We don't exactly have causal evidence. So we're short on time. We have another piece of evidence for that, but I'm not going to explain it to you because it takes a little bit of understanding and explanation. But this is basically like a pseudo-random experiment. If you're interested, read the paper. Maybe the biggest takeaway from this is websites with Google Ads enabled are much more likely to adopt TCF. So we're kind of coming to towards the end of the talk. There's just 5 minutes left. And what I would like to turn your attention to, so basically the summary up to now is that there were these two kind of pro-privacy signals, platform for privacy preferences, P3P, the first one, and do not track, the second one. And they weren't widely adopted. Basically, the ad tech vendors refused to respect the signal, whereas for TCF, you can see in our measurements how widely it was adopted, but also to all the people who recognize that dialogue, you can see for yourselves how widely the TCF signal has been adopted. But the final part of the talk, I'd like to talk about this final signal, the global privacy control. So the global privacy control works in a very similar way on a technical level to do not track, apart from rather than sending a signal saying do not track, it sends do not sell. Many of the same individuals were involved in designing both of them. And you might ask, why is there a difference in language here? And the answer to that is that whereas in 2009, when Do Not Track was released, there was basically no legal basis for the Do Not Track signal. The global privacy control, the Do Not Sell signal, is specifically tailored to apply to the Ccpa. So the Ccpa is the California Consumer Privacy Act that gives residents of California a right to tell websites, do not sell my personal data. So the difference is here that the signal directly references a law. And the Attorney General in California has actually tweeted his support for this specific signal, the global privacy control. So for Californian residents, they can maybe have good hope that this allows them to tell websites, do not sell my personal data. Now, I'm guessing everyone in this audience is in the European Union, so you might ask, what rights do I have? If I adopt the global privacy control, which currently is only officially adopted by the Brave browser, but we expect it will be adopted by the Mozilla browser soon. I think it's in some beta versions. Yeah, what can we as residents of the European Union gain protection from the global privacy control? And here I think this question motivated a second experiment, and this is the final thing I will present to you guys. And this relates to a potential contradiction. If you think about the global privacy control, which says, do not sell my personal data or do not track, they are in some sense in contradiction with the TCF signal, which says, yes, you can use my personal data for these purposes. So we kind of asked the question, is this contradiction? Because you can imagine one user could send both signals. Is this contradictory signal a reality in the world? Now, this will look somewhat confusing. It's maybe useful to first look at the top here. So the top two bars show all users who do not send the do not track signal and they do not send the global privacy control signal. They just don't send a signal. And what we did was for 1,600 of them, we presented them the Quantcast dialog. And we tried to see what percentage accepted, what percentage rejected. We found that 90% of those users accepted the terms and conditions of the Quantcast dialog. Then what you will see here is the next two bars relate to those users who send the do not track signal. So of the visits to the web page, 3,500 had the do not track enabled, versus 13,000 who did not. And again, we did the same thing. So for those users who send the do not track signal, we showed them a Quantcast dialog, and we found out how many accept, how many reject. What you will see here is about just more than 80% of those users actually still accept. So they send this contradictory signal. On the one hand, they say, do not track. And on the other, they say, we accept the terms of your data processing. And there's a similar story for the global privacy control. So this kind of shows that although privacy preference signals kind of have some promise, one of the problems is users can send contradictory things. I'll skip the question of blocking in a sec, but, well, actually, no, I'll say it because it's maybe useful for you guys. So you'll see here that actually for the global privacy control, the majority of users just block the dialog. So that means although we tried to present it to them, the browser never loaded it. And that's because most of them are using kind of privacy browsers and add-ons that just block those dialogues. So if you have one practical takeaway from this talk, you could maybe look into the solutions. So this would be, for instance, the Brave browser or Mozilla browser, the Privacy Badger add-on that can kind of block these annoying privacy consent dialogues. So that is an important takeaway from the talk. But another thing we showed is that there is a statistically significant difference in the privacy preferences expressed. Users who send the global privacy control are much less likely to accept the terms of the consent dialog. So we suggest that this shows that these signals do actually express something about the user's privacy preference signals. And you might ask yourself, why does still the majority of users accept the terms? And there's a big body of research looking at what they call dark patterns, so dark patterns are contained in the dialogue and they push users towards consenting. So I'm going to have to skip these slides and I'll just get to my conclusion so we can start a discussion. But essentially, the main takeaways from this talk is for a long time now, the privacy community and the web community, AdTech community, have been trying to come up with a standard way for users to express their web privacy preferences. In the past, those efforts have failed. So the Platform for Privacy Preferences and the Do Not Track Signal, they both failed, arguably because they lacked a legal basis for enforcing them. Whereas our measurements have shown that the TCF signal, which was designed by AdTech, has become the dominant signal as of 2021. And we argue, and you can understand this point better in the paper, that was driven by a mixture of the General Data Protection Regulation and also those websites, AdTech partners. Cool. So yeah, I have more slides. So we can, if a question is related to the slides, we can go into the slides. And otherwise, I welcome your questions. And thank you for listening to the talk.